Hey there! I'm absolutely thrilled to share some insights into the world of palindromes, especially diving deep into the Python implementation. Imagine a string, say racecar or level, and just by reading or writing it in reverse, you get the same sequence. It's like magic, isn't it? So, to begin with, let's talk about what a palindrome truly is. At its core, a palindrome is a sequence that reads identically forward and backward. Whether it's a sentence like a man, a plan, a canal, Panama, or a string of digits 1 to 3 to 1, if you reverse the latter, it still represents the same data. Now, why would someone care about checking if something is a palindrome, right? First, it's simple entertainment, testing your coding prowess to create something like a race car in mere code. Next, it's about data integrity, especially in error-checking methods where palindromic strings can signify accuracy. Diving into the basic implementation, we often do this by comparing the original string and a reversed one. In Python, we are blessed with elegant one-liners for this purpose. Here's how it goes traditionally. Python definite is underscore palindrome bool return s is equal to s, so we slice the string in the reverse using s. Cool, huh? But hold on, let's deep dive into optimizing this baby for performance. Especially since, as freshers in IT, we want to ensure our logic is top-notch not just in accuracy but also efficiency. Firstly, avoid unnecessary conversions and functions that take time. Our slice technique is lightning fast and doesn't require us to reverse the string manually or use complex string operations, keeping our solution lean. But we can still tune this. Suppose we've been asked to ignore case and non-alphanumeric characters, and we need to consider this huge string of characters, which might even touch upon some security aspect where this check could be part of an input validation process to avoid injection attacks or just simplifying the validation of user inputs. We can refine our approach to only consider alphanumeric characters, thus Python definite is underscore palindrome bool cleaned underscore s is equal to dot join, return cleaned underscore s is equal to cleaned underscore s. Now, this one evenly cuts the cloth, trimming the non-alphanumeric characters, converting to lower case in one go, and checking for a palindrome. Looking at reliability, one aspect we have to consider is how our function handles empty strings and strings with a few odd characters. We need to ensure our function returns a sensible output or raises an understandable error when faced with such situations. When it comes to security, as freshers, we are always wary of common pitfalls, like SQL injections. In Python, using our palindrome checker in a database context as preprocessing can be a preventive measure to catch any malicious strings that a hacker might try to inject. Scalability enters the picture when dealing with enormous datasets or strings. While writing our function is straightforward, ensuring it scales without becoming a bottleneck requires mindful coding practices, like using generators for memory efficiency or employing multiprocessing or threading in case of extremely long strings that need to be checked swiftly. As for future trends, Python, being dynamic and evolving, may see shifts in how palindrome checks might be done. We could leverage more concurrency and parallel processing as computing resources and algorithm design improve, and we can expect enhancements from tools built upon it, such as auto-differentiation that could, hypothetically, optimize our scripts over time. That's quite the tutorial on palindrome checks in Python, with touches on basic to advanced considerations for freshers stepping into the IT world. For more captivating discussions, and to not miss any upcoming webinars or tech talks, drop by Neeraj's digital abode at neeraj.qzz.io. And don't forget to subscribe to the TechLab channel for daily doses of tech wisdom. Catch you in the next deep dive.